This week we've been studying geometry, a little sneak peek of what's in store for you next year. And part of the geometry course are 3 or 4 standards on trigonometry. Trigonometry might look intimidating or sound complicated, but it's really just comparing side lengths of right triangles. So trigonometry has to do with right triangles and the ratio of their side lengths. So you have three basic trigonomic words, functions. It's sine, cosine, and tangent. All right, and those three words, sine, cosine, and tangent, are usually represented by just their first three letters. So you have sine, you have cosine, and you have tangent written like that, S-I-N, C-O-S, and T-A-N. And what does that mean? What do those represent? Those represent fractions. All right, each one of these is a fraction, so I wrote equals and I put a fraction bar on there. I just haven't told you what the numerator and the denominator is. So it's sine, cosine, tangent of an angle. So this is where it starts to get a little bit tricky. So let's label our vertices here of our triangle ABC. So we'll call this triangle ABC. Now you can find the sine, cosine, tangent of angle A, and you can find the sine, cosine, tangent of angle C. We're not going to find the sine, cosine, tangent of angle B, which is a 90-degree angle. Eventually you will learn that there are sine, cosine, and tangent of 90 degrees, but you won't get into that until algebra 2. So we're not going to worry about the B right now, just A and C. So let's look at A first. Let's find sine, cosine, and tangent of angle A. So I put a little A after my sine, cosine, tangent. So we're going to find the sine, the cosine, and the tangent of angle A. Well, to do that, we need to know the lengths of our sides because that's what these fractions are, just going to be the lengths of sides of the triangle. So I'll just go with a typical 3, 4, 5 triangle. And if you check that with Pythagorean theorem, it works. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and the square root of 25 is 5. So that's a good, sound right triangle right there. So sine of A, I'm just going to go straight to the answer. Sine of A is 3 over 5, cosine of A is 4 over 5, and tangent of A is 3 over 4. All right. Why is that? Well, it's because of opposite, adjacent, and hypotenuse, those three words. All right, all three of these sides are going to be given a name, either opposite, adjacent, or hypotenuse. Hypotenuse you're familiar with. That's the diagonal side, the longest side in a right triangle. So we're just going to go ahead and label that the hypotenuse right now. So 5 is always going to be your hypotenuse. And you might have noticed that 5 is the denominator in sine and cosine. So I'm going to use an H for hypotenuse, a capital H, and we've got half of sine and cosine done already. It's hypotenuse as your denominator, and that never changes. When you're trying to find sine or cosine of an angle, the hypotenuse of that triangle is going to be your denominator. Now the rest of our numbers here are 3, 4, and 3 and 4. Those are these two sides. So we have to give those sides names. Well, we're looking from the perspective of angle A. So how would you describe this side 3 as compared to angle A? You would describe it as the side across from the triangle or opposite of A. So we're going to say this is the opposite side. 3, so sine deals with 3 over 5. That's the side opposite of A over the hypotenuse. Cosine, use the other side, 4. That 4 is right next to A. 4 is a side that is part of angle A. Angle A is made up of the hypotenuse and the bottom of the triangle. Well, the 5 is already taken. That's the hypotenuse. This side right here is going to be called adjacent. Now, adjacent, if you look that up in the dictionary, it's going to say it means next to. So 4 is right next to A. Well, some people argue and say, well, 5 is right next to A as well. That's true, it is, but 5 already has a name. 5 is the hypotenuse. 4 is the one that needed a name, so that's the one we're going to call adjacent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is just opposite over adjacent. So tangent of A, you're starting with A. The side opposite of A is across the triangle, that's 3. And the side adjacent to A that's not the hypotenuse is 4. So it's 3 over 4, opposite over adjacent. So those are your 3 ratios that are the building blocks of trigonometry. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So how are you supposed to remember that? Well, there's a nice little acronym that gives you something to remember this by. And it's called Sohcahtoa. There you go, Sohcahtoa. Yes, you stubbed your toe, it's throbbing, you're shedding tears, so you want to soak your toe in some warm salt water and make it feel better. So you Sohcahtoa. So is for sine, Ca, C-A-H is for cosine, and T-O-A is for tangent. So S stands for sine, C stands for cosine, T stands for tangent. Sohcahtoa. So the O, the H, and the A are your opposite, your adjacent, and your hypotenuse. So sine is O over H, opposite over hypotenuse. Cosine is A over H, adjacent over hypotenuse. And tangent is O over A, which is opposite over adjacent. Sohcahtoa, the magic acronym of trigonometry, will help you remember what the ratios of sine, cosine, and tangent are. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So let's do this again, but from angle C's perspective. So now we're going to do sine, cosine, tangent of angle C. So the hypotenuse doesn't change. The hypotenuse is still 5. So I'm going to leave 5 there. That doesn't change. The denominator of cosine and tangent is always the hypotenuse. The opposite and the adjacent sides are going to change now. Because when you look from the perspective of C, which side is across the triangle? Which side is opposite of the triangle from angle C? It's 4. So now our opposite is side from C is 4. So the sine of C is 4 over 5. The cosine of C is the 2 sides that make up angle C, the 3 and the 5. Well, the 5 is the hypotenuse. The 3 is what we call the adjacent side. So it's 3 over 5. And then tangent is opposite over adjacent. So what's opposite of C? It's 4. And what's adjacent to C? 3 and 5, but 5 is the hypotenuse, so we use 3. So it's 4 over 3. So Sohcahtoa works. It doesn't matter what angle you're starting with, this corner or that corner. You just have to look from the perspective of that angle when you're filling out your ratios of sides. So if you're looking from A, 3 is opposite of A. If you're looking from C, 4 is opposite of C. If you're looking from A, 4 is adjacent to it. And if you're looking from C, 3 is adjacent to it. So that's what the problems are today. They give you a triangle with 3 sides and they ask you to find sine, cosine, and tangent of one of the angles, maybe both of them. And you just got to, so all your answers are going to be fractions. You just got to find the fraction using Sohcahtoa, and hopefully you'll be able to do that.